Alright, so before I jump into 5.2 notes, I want to take a look at a activity we did yesterday in class where we were trying to draw the perpendicular and angle bisectors for each side. This is kind of what sets us up for our notes. We didn't do constructions with a compass. We're going to save that for later in the chapter, but we're actually just using protractors and rulers to draw these things. So I tried to give you all three types of triangles. So this top type of triangle is an obtuse triangle because it has one angle greater than 90. And to draw a perpendicular bisector, so remember that's 90 degrees through the midpoint of each side. So that's what we have to do. We have to go 90 degrees through the midpoint of each side. And I'm going to just kind of draw these here really quick. And I'm actually going to kind of just guesstimate them. But I would measure this bottom line with a ruler and I would find the middle. So I find the midpoint. And then lining up a straight edge so that I could figure out exactly where a right angle would be. I could use my protractor. I'm going to use a piece of paper here. And I get my mark and I'm going to draw a line. And let me grab a ruler. Make sure this thing's nice and straight. And I'm going to connect these two dots and draw this line and extend it way on out. So right there I'm 90 degrees and I'm through the middle of a side. And I repeat this process. I come over here. My board is quite a bit bigger, but I measure this. It's about 17. So I'm going to go at about 8.5. So this was 17. These guys were 8.5. And that's basically what you do. You use a ruler to measure it. And then you put your protractor on there, or you could use a sheet of paper or anything with a straight edge. And I'm going to get a 90-degree mark right out in this area. And then once I got my 90-degree mark, I can hook these two together. And I want to extend it all the way through to where those two lines cross. So there's two of them, and then I kind of do the final one. My third side on my board here is about 33 inches. So that'll put me at about 16.5. And I connect those points together with the 90-degree point. So I'll use my protractor here, get my 90-degree point, which is right up there. So I basically repeat this process 3 different times. And again, I have 90 degrees and these two sides are equal. And what you're going to notice is they should all, if you're accurate, they should all meet at a certain point. Now notice for an obtuse triangle, they met outside the triangle. The 3 perpendicular bisectors met at a place that lives outside the triangle. Now during the activity in class, or if you finished it at home, you should see that in a right triangle, and I'm just going to kind of freehand sketch these for time's sake, but when I do my perpendicular bisector and I come through and I do that, and then I pick the other one and I come through and I do that, and then I pick my other one and I come through and I do that, you're going to notice that they should meet, if I do this really accurate, they should meet right on the hypotenuse. So for a right triangle, they're going to meet right on the hypotenuse, right on the exact side of the right triangle. And then down below we have an acute triangle, and when we do the same thing for this one, and I find the midpoint of every side, so I find the middle, do it at 90 degrees. I find the middle, come in at 90 degrees, and then I do it one more time. I find the middle and come in at 90 degrees. This time they should meet at a point inside the triangle. So when you have an acute triangle, they actually meet on the inside. And these points where they meet have a special name, and we're going to jump into that when we get into the 5.2 notes. So that whole first page was all about perpendicular bisectors. Now, I'm only going to do one for this problem here. I'm not going to do all the 3 triangles because we worked on this in class. But for angle bisectors, you want to measure how many degrees each angle is. Sorry about that. About ripped the headphones off my head trying to reach over and grab my protractor. So on my board, when I measure this angle, it is about 28 degrees. Mine's about 28 degrees. So when I divide that by 2, 14 degrees would be the middle of this angle. So 14 degrees is somewhere about in here. And I'm going to connect the vertex or the corner to that dot and just extend it through. Now I want to point out that I don't know where it comes out the other side of the triangle, and really I don't care where it comes out. This is not at the middle or anything special. It just kind of comes out the other side. And I'm going to repeat the process for this angle. This big obtuse angle here is about 120. So I'm going to put a dot at 60. So this angle is 120. I'm going to divide it by 2, and it comes out to be right at 60 degrees. So I'm going to go ahead and get my straight edge here and connect those back up. So basically what I've done is I've made this angle equal this angle. I've made this angle equal that angle. And then I have to do it one more time. And if I do this right, they should meet right at the point, right through there. And I can tell that I'm off a little bit because that angle is supposed to equal that angle. I didn't measure it with a protractor, but I kind of cheated. And these 3 guys meet at a certain spot. Now what you're going to find, I'm not going to do all the different triangles, but you will find that when you do this and you split all of the angles in half, they should always meet inside the triangle. So angle bisectors always meet inside the triangle. Perpendicular bisectors could meet inside, outside, or actually right on the triangle. Alright, so I want to move from the activity and I want to move into the actual formal notes from 5.2. So this is what I was asking you to work on at home, and a lot of these notes are filled in for you, so we're just going to kind of talk about them. And some of this is vocabulary, just kind of getting the names down. So bisectors of triangles. First one is called the circumcenter. So the circumcenter is found when you do the 3 perpendicular bisectors, the ones I was doing first. Those guys meet at a point called the circumcenter. And there's something very special about that point. And this is probably the most important part, is it's equal distance from the vertices or from the corners. So remember I told you earlier that they can be inside, outside, or on, and these are the 3 scenarios where they're inside, outside, or on. So when I have 3 perpendicular bisectors and they meet, here's what's special about it. The distance from this meeting point, okay, called the circumcenter, the distance from that point to every vertice, so this distance, to this distance, to this distance, they are all going to be the exact same distance from every single point. And what that means is, you'll kind of see it in a second, so from the circumcenter, the distance to this vertice should be the same as the distance to this vertice, should be the same as the distance to this vertice. It's equal distance from all 3 corners. And again, right here, it's going to be equal distance from this corner, equal distance from this corner, and equal distance right there to that corner. Now, in geometry, whenever you have a point and you have other points that are equal distance away, it can form a circle. So the circumcenter is basically the center when you circumscribe a circle. So circumscribe means to wrap it in a circle. So that's what the perpendicular bisectors create. If you kind of link these things together, perpendicular bisectors create a circumcenter. The circumcenter is special because it's equal distance from the corners. That's the main thing that you need to know about circumcenters. Now, incenter is just a special name that comes from the angle bisectors. So I start off by finding the three angle bisectors like we did on our activity. The point where they meet is called the incenter, and the incenter is not equal distance from the corners, but equal distance from the walls, from the sides. And remember here that so if this is that meeting point, equal distance to the sides means at 90 degrees. That's the distance from a point to the side is 90 degrees. And if these are all equal distance, you're going to find that you can put a little circle inside of a triangle by using the angle bisectors. And something I noted when we did the activity is that it's always inside of the triangle. That special point, the incenter, is always on the inside. Alright, so let's actually go to the other side where we can get some problems in and try to work some numbers. So number one, if n is the circumcenter, find these different values. Well, what I need to do is I need to understand who made the circumcenter. So alright, perpendicular bisectors made the circumcenter, and the circumcenter should be equal distance from the vertices or from the corners. So looking at this drawing here, find the distance from N to Q. Well, if N is the circumcenter, it should be equal distance from every corner. Well, I have one of those measurements. To this corner, they're telling me that it's 5.64. So if I need NQ, which is this line, that should also be 5.64 because it's equal distance away. PV they give me right here. PV is listed as 5.47, so that one I can just steal right from the picture. How about TR? Well, TR is the distance from here to here. Now, there's no number there that represents TR, but when I look to the other side, QT, I do have a distance there. And because I know that the perpendicular bisectors are the ones that created point N, I know that this side right here must be equal to this side at 90 degrees because TN was a perpendicular bisector. So I know that if QT is 3.95, the same has to be true for TR. It's got to be 3.95. And now the distance from Q to N, well, that's kind of a goofy question because QN should be the same as NQ. So 5.64. Alright, number two, find the circumcenter. So how do you make a circumcenter? Well, perpendicular bisectors. And perpendicular bisectors aren't too bad on the coordinate grid, especially when you have horizontal and vertical lines. Now, technically I don't need all three. Really, I only need two. So let's just focus on this side down here on the bottom right there. If we find the midpoint, so this goes from 0 to 4, so the midpoint should be right there at 2, and I hit it at 90 degrees, there is one line. And then when I do, so there's my little perpendicular bisector, and then when I do this other side, it goes from 0 to 6, so the middle is going to be 3, and there's my other line. It looks like this right here is the circumcenter. Alright, and that would be at the point 2, 3. So I've just found the circumcenter, 2, 3. And remember from the activity that if it's a right triangle, it should be right on the hypotenuse, and that one was. So that worked out nice for us. Scrolling on down, number 3. So now I got to kind of switch gears a little bit. It says that P is the incenter. Well, I got to remember that the angle bisectors makes the incenter. And then the fact about that is it's equal distance from the sides at 90 degrees. So let me kind of look at this here. I have an angle bisector because it says P is the incenter. Well, who made P? This angle bisector, this angle bisector, and they don't show it, but this angle bisector. Those are the three creators. From that, point P was born. Boom, you got point P. Now I know that the distance from P to Q is 9. And I'm also going to know that the distance from P to ED is 9. And I'm also going to know the distance from P to CE at 90 degrees is 9. So the blue lines created the incenter. They were the angle bisectors. The red line is the result. The red line is the result. So let's see if we can answer some questions. PCQ, find the measure of PCQ. Where the heck is PCQ? So PCQ is this angle right here. And if CP is an angle bisector, then it's got to match. You have 36. This has to be 36. PDQ should be this angle right here. So we're trying to find PDQ. That's angle PDQ. Well, we're going to need to kind of go around the triangle and get some other measurements. I got to erase this line. It looks like that was 40 degrees. So if this corner is 40 degrees, this one up here was 36 and 36 for a total of 72. Right now I'm at 40 and 72. Let's add those together, and that's 112. Subtract from 180. That means that angle D, the whole thing over here, is 68 degrees. Now, PDQ should be exactly half of that, because PDQ is just this sliver up here, and this was an angle bisector. So when I take 68 and divide it by 2, I believe PDQ is 34 degrees. And what's the distance from P to ED? Well, that would be this line right here. P to ED is 9. The distance should be equal to every side. Number 4, solve for x. All right, this one they don't tell me whether I have an incenter, a circumcenter. So I kind of have to look at the lines and see how they're being drawn. Well, I do see that this line definitely is an angle bisector. Okay, that line right there is definitely an angle bisector because I do have these arc marks that tell me that. Now, I do not know if this blue line, I don't think it's a perpendicular bisector. I do see perpendicular, but I'm missing my bisector marks over here. So I think they were trying to trick you to make you think it was a perpendicular bisector, but it really wasn't. It's really just an angle bisector. So the blue line is an angle bisector. This blue line is an angle bisector. So the angle bisector meets at a place right here in the center. This must be an incenter because angle bisectors created him. And what's true about the incenter? It should be equal distance from the sides. So that means that the distance right here should equal the distance right there, which should equal the distance right here. All three of these distances should be the same. Well, luckily, I have an expression for two of them. So I know that 2x has to be the same distance as x plus 3. And when I solve these both for x, I get x equals 3. And so that one was a little bit tricky because I wasn't really sure exactly who made who. A little ACD song there. ACDC. Who made who? All right, number 5. See what's shaking on this one. Again, who created this mess? Was it perpendicular bisectors or was it angle bisectors? Well, I do not see any perpendicular bisectors on here. I do see an angle bisector, and I do see an angle bisector. So they're the creators. They created this point, which again is an incenter. Angle bisectors create the incenter. And the incenter's claim to fame is he is equal distance from the sides of the triangle. So same type of idea here. X plus 2 distance has to equal the 2x minus 3 distance. I'm going to minus an x from both sides. I'm going to add this 3 to both sides. And I find out that x equals 5. Alright, holy smokes, number 6 looks a little bit rough over here. Number 6 has a lot going on, so let's see if we can kind of make some sense of it. So what point is what point is the circumcenter? Well, remember who created it. The perpendicular bisectors create the circumcenter. Alright, so where are the perpendicular bisectors? Well, this line right here for sure is a perpendicular bisector because I have those 2 tick marks. And this line right over here is a perpendicular bisector. Well, where did those 2 lines meet at? Those 2 lines met right here at point R. So point R is in fact the circumcenter because I know who created him. Now, trying to find the incenter, I'm going to kind of get rid of that stuff. Trying to find the incenter, well, angle bisectors create the incenter. So let's find these angle bisectors. Well, here is an angle bisector. Here is an angle bisector. And they don't draw one from C. They don't draw one, but I only need 2. So it looks like the angle bisectors meet right there at a point T, which would be the incenter. So a little bit tougher lesson, I think, just because a lot of the triangles have a lot of different shapes going on. But the big ideas, the big facts that you need to know are, number 1, perpendicular bisectors meet at a special point called the circumcenter. And what you know about the circumcenter is its equal distance from the vertices or the corners. And on a related note, angle bisectors do something very special. They meet at a point called the incenter, which is equal distance from the sides or the walls at 90 degrees. The other little thing was the incenter is always inside the triangle. The circumcenter could be inside, outside, or on the triangle, depending on if it's obtuse, acute, or right. Alright, I think we're ready to rock and roll, and I will see you in class tomorrow to get after the 5.2 practice. See you.